Hello. So today we are going to demonstrate our project, autonomous vehicle rental clouds. So the main uh, purpose of this project is so more and more people are like using the cab system these days for commuting, and sometimes there will be like less drivers or the ride will take like too much time to come and pick you up. So the the concept of this is to eliminate the uh, physical drivers and substitute them with autonomous vehicles cars. So AV vehicle cars are driverless self-driving cars that can like go to different locations without any human intervention. And AV vehicles are like they can supposedly be more secure than normal uh, uh, user-driven vehicles because they can be trained for better driving purposes, and we can also like gather their uh, sensor data and everything so that we can be monitoring them remotely. So the main aim again is to lack of driver availability and for like quick pickup solutions. So we thought this will be a better solution for it. So in this project, we are going to build an autonomous vehicle rental platform and connect it to a simulator software called Carla Simulator to simulate self-driving vehicles and bookings in simultaneous fashion. So in future, when this system goes live, the simulator will be like substituted with actual autonomous vehicle cars. So we'll be like implementing a cloud-based vehicle booking platform for this, so that clients can access easily through their phone or website. So the main functional requirements and features for this project would be to develop cloud-based infrastructure for autonomous cars and uh, execute like uh, paths and all for send the path details to the car so that car can travel in that direction, pick up and drop off users who booked it. So uh, a simulated autonomous vehicle will be used in this project that can track and control its status, and it will be roaming in a simulated environment. So, and there will be like two databases for this. One database is a MySQL SQL based database. So that contains all the user details and cars trips details. And one more database is a NoSQL based database that will be used to store vehicle details such as the sensor data and as well as images if any images are captured from the car. So this will be the operations supported by the platform, management of users, management of vehicles, management of trips, communication between vehicles and servers, management of billing. So the management of users will be like adding and deleting new users. Management of vehicles is like each user can add a vehicle of his own autonomous vehicle, and trips is for booking and cancellation of trips. Communication between vehicles and servers is for getting the path details and um, destination details, and management of the bills generated or invoice for a particular trip. The main persona who will be using the system is we have categorized them into three people. So the first one is a business user um, who will be like using this platform and booking the vehicles as taxi services. The second user is a car owner who can register his cars into the system. So these cars will be booked by business users. And then there is system admin who will be like overlooking the system. This is like our core infrastructure system design. So all the entire the application is like hosted in AWS using different services. So the front end part of the platform, which is built by React.js, built using React.js, is hosted in an EC2 instance, and the backend server developed using Node.js is hosted in another instance. And then there is one more EC2 instance which will be used for hosting Carla simulator. So we have created this design in a distributed systems architecture. And as Carla requires more computation power for simulations and other this thing, we have like used a high GPU machine for that. And the backend server and Carla is interconnected to two different types of database. The first one is Amazon RDS service. So with this, we'll be connecting to a MySQL based database which contains all the user details, trip details, and invoices. And the next one is a document DB connected to MongoDB that will be used for storing all the sensor details and images uh, data coming from the Carla simulator. So the images will in turn stored in S3 bucket as it supports large data storage. All the instances are like uh, scaled using auto scaling group so that to ensure constant availability of the services. And all these services are washed using Amazon CloudWatch service, which gathers data from and data and health checks, performs health checks on all the instances 24 by 7. So these are like the Carla simulator functionalities. So the first one, why we used is because it's an open source simulator software and it supports API support directly with Python and JavaScript. So we have used like a Python based this thing in our project. So we have like two different backend servers for this. So one is Node.js based server for interacting directly with the front end platform by the users. And then there is Python Flask server, which will be used for communicating with Carla simulator. So this server also provides like trip controls, like telling an AV to go to a particular location or destination. And when the trip is not initiated, so it will be in autopilot mode. So this is like the flow from the for the application. The Flask server will be like getting the request from the backend Node.js server, and it will perform the vehicle operations accordingly. The vehicle operations include storing logs, sending the vehicles to a location, and then storing logs and other details in MongoDB. And there is also incident logging. So if any collision occurs, we can know through this Carla simulator. So this is trip management. Trip management consists of like four different steps. First, it's to drive to the pickup location, pick up the passenger. So we have like added like a 5 seconds time. So the car waits at the pickup location for 5 seconds, and then just for simulation purposes, and then it picks up the passenger and drives to the destination, drops the passenger, and then goes back to autopilot mode. So this is like the state diagram for a car. So this will be like the car will be like in the created state initially, and it will be goes to idle state where it will be in autopilot until a trip is received to the car. Then it goes to the pickup location, and then picks up the passenger and heads to destination. And after that, it again goes to idle state or autopilot state. So this is like the simulator environment map that we used in Carla simulator for our cars. So the red dots indicates the cars added by our platform. So these will be like initially um, in autopilot mode, just roaming in the map. So this is like a front-end infrastructure. So each component will be like using props to send the data, and each component will be communicating with set of APIs. And so the next details consists of screenshots of our dashboard details of our application. So this is like the main login page. So here user can register or sign in. So this is a registration page for the application. So in role, we can select either a user or owner or admin, and the account will be created based on that. So this is like the user dashboard. So we have integrated Google Maps API using Google Maps using Google Maps API. So the user chooses a pickup location. He can point it. For this demonstration purposes, we have like added predefined set of points for pickup and drop off location. And then user can choose car type, and then he can just click find ride. So this is like searching for nearby cars loading, and when a car is like uh, assigned for the user, so he can see the details on this dashboard. So the next will be continued by my teammate Vinith.
Thank you, Manish. Can you give me access, remote access?
Uh, you can go ahead. I can click next.
Yeah, yeah. So this is the basic owner's dashboard, which we can see in our app. So as you can see, the owner can enter the manufacturer, which is car is, and then the model, and then the register number, and press add car. Once he presses add car, the car will be added to the dashboard. In the main dashboard, you can see what the manufacturer that car belongs to, what is the model of the car, how many trips it has completed, etc., etc. The car is also allotted a unique ID, as you can see 1001 in this case. And also on the right side column, you can see the total revenue generated by that particular car for that particular owner. Using the remove button, the owner can add and remove cars at his convenience so that he maintains whatever cars he wants to maintain on the app. Can you go next? So yeah, this is the dashboard for the admin. The admin has access to pretty much everything, as you can see on the left hand side. He has access to see the what are the users who are using the app, what are the cars that are currently listed in the app, the trips that are being completed, processed, or still being processed or in the process, the billings that are being generated, and he can also track the cars using our tracking system, where they are, what they are doing, etc., etc. So when you press on the car, when you can go back. So when you press on the cars, this is the dashboard. You can see this again, all the information regarding cars, like car ID, manufacturer, model, registration, owner ID, etc. Even the admin can add a car, remove a car using delete, and do all the stuff which our owners are able to do. So this is the basic invoice of a trip generated after a trip is completed. This includes all the user unique invoice number, the tax, and the address that it is billed to. The owner, the admin also has access to the analytics, where he can see the trips, what location are the trips being booked for, and what are the locations that are the trips are being dropped off at, and etc., etc., so that he can position his cars in the high traffic areas for his app to earn more. Yeah, next. This is the basic ERD diagram of our database. You can see there are the 4 5 users, like user, admin, cars, tables, trips, billing, etc., and these are all the columns in the that particular table. These are all the relations between these two tables. This is very basic SQL ERD diagram. So we have used a lot of APIs on our backend. Backend APIs are usually endpoints are created using Node.js, and all the APIs are deployed on EC2 instance. The backend server will be interacting with RDS for data. RDS is the database. It will be interacting with it to fetch and store the data. The What are the tasks that API is doing includes registration of users and car owners when they first try and register to the app, the authentication of the users, and same for the owners as well. Searching for the rides, whenever you search for the rides, that happens to call an API. And whenever you book a ride, user books a ride. And whenever owner adds a car, then is also one particular API is called, again for removing car. And whenever the earnings needs to be checked, one of the API is called. So how the communication from backend to Carla happens is explained in this slide. Uh, when the communication between backend and Carla happens is explained in this slide. Whenever we initiate a trip between 2 points that needs Carla to be involved, so the backend calls Carla to process all the information, and then again to give the real-time details of the trip to the user, the Carla sends information to the backend, and which in turn sends to the front end. Initiate a AV car creation and deletion. This also involves Carla. Receive trip completion information once the trip is completed, same as initiating the trip, but in the reverse direction. And receive a car nearest to the customer's current location. Whenever you request a car, to search all the cars which are available in the nearest location, that needs communication between backend and Carla again. So this is a screenshot of all the APIs being called. As you can see, once a register user is being registered, a post API is called, and then same for user login. Uh, Again, whenever the admin requests all the users, get all users API is called, user details API is called, whenever it tries to edit, put method is called for this particular API. Whenever the delete user delete method delete action is done using this delete user API. So these are the APIs that are being called, and this is just a screenshot of Postman where all the API stuff is happening. This is a screenshot of our SQL database, which is MySQL DB. The name of the database we is Carla, and the tables that are there in the database are a billing, car, trip, and users. Uh, as you can see, and then you can see that the user IDs are being generated automatically. The password is being hashed, and whenever the post API is called, like a new user enter API, the all the details of the user, such as username, first name, last name, address, phone number, and of course the role is also being saved into MySQL database. So this is a screenshot of our RDS monitoring system, where it shows the different actions that are being performed on our RDS database. As you can see, there are graphs for CPU utilization, DB connections, free storage, freeable memory, read IOPS, etc., etc. We will see more about all these actions in upcoming slides. This is our logs for Carla. These are all the tables that are there in our Carla database, which is nothing but a RDS database. So collision log, trips, vehicle log, and vehicles are four of our tables, and these are all the information that are stored in our vehicle logs. As you can see, Carla vehicle log table has all these columns such as ID, vehicle ID, trip, etc., etc. RDS is one of our MongoDB type database. So let's look at our cloud platform, that is AWS. The software architecture in which a single instance of software runs on a server but not on an actual.
Bro, once pause.
So let's look at the our cloud platform, why we used and how the system is being designed. So these are all the system level designing techniques which we used, which are nothing but multi-tenancy architecture models, which is single tenant application, etc., etc. Single tenant database, complete multi-tenant, etc., etc. So we have used AWS auto scaling, as Manish explained, for which allows us to smooth scaling of the application, so that so many of number of users can connect at the same time. So these are all the screenshots for GPS CPU utilization, and again some analytics for disk utilization, etc. When we are using Carla, these are all the three C2 instances which we have hosted running. This three screenshots of that. So this is the screenshot of load balancer, and which is application load balancer. Next,
Hmm.
metrics for front end in application load balancer. As you can see, there is a spike whenever the front end is called, and again the same metrics for back end as well. Thank you.
Yeah, thank you.